a Garrett GTCP 331-200ER. It later became an Allied Signal APU when Allied Signal bought out Garrett. And finally, Allied Signal was bought out by Honeywell. So, much like the aviation industry has combined, merged, so have a lot of the manufacturers. So now it is technically a Honeywell 331-200ER APU. They also built a revised version for the 767-400. They took all the stuff that went wrong with this one and they made it better on the 767-400. So that's a pretty cool segment when we get to next week. But yeah, we have, let's see, we have a controller. That controller is located in the aft bag bin in the door jamb area, otherwise known as, I think, the E6 rack, along with a battery and a battery charger. In the flight deck, we have a simple control. It is a switch that is off, on, or start, and we have a run and a fault light. We also have an APU fire bottle, fire shutdown handle, T-handle, along with two bottles. Of course, the APU is located back here on the tail. That shouldn't be anything new. And then we also have the remote control panel called the P40, which is on the back of the nose gear. It's got a fire warning horn. It's got a red indicator light. It has an armed and bottle discharge lights. It's got a shutdown button, and it's got two bottle discharge buttons on the back of that gear, so that you can shut it down, and then you can shut it down, and then you can discharge the bottles. So. Let's see, what else do we need to know? It provides 90 kVA to the service ceiling of the aircraft, and it is capable of providing pneumatics up to 19,000 feet, and it is capable of starting at 43,100 feet, which is an ETOPS requirement, which is the ceiling height of the aircraft. Any questions so far? Alrighty. This is that E6 rack that I was talking about, and right here on the right you see the ECU, the engine control unit for the APU. This is the brain to the APU, and this is also where you're going to perform any bite. You're going to have to come back here to the E6 rack, you're going to have to open up the cam locks, and you're going to have to interrogate this box to do a bite check on the APU. This right here is, of course, your battery, and this right here is your battery charger. There's a bunch of stuff located up here inside this panel, a bunch of relays and a bunch of big heavy feeder wires. That is for starting and starting and a couple other things. So you'll see a relay panel up there when you look in that compartment. The APU battery weighs about 70 pounds. It is actually equivalent to a ship's battery. They are the same part number. There is really no good way to get it in and out of there. The best way to change it is to find a lift truck or a Wallard and get it right up into the door in the right spot, and you should be able to transfer it into the rack that it sits in and then bolt it in. The other second best way is to get a skyjacker. There again, the electric ones seem to work the best, and put the battery up on it and then just transfer it from the doorway of the skyjacker into the compartment. This aircraft was equipped with a few chain hoists. I don't think there's one back here for this, so it is going to be a manual lift. Sadly, you can only fit one person in there. So there again, you got to be capable of lifting the 70 pounds to get it in there. Here is your P40 panel on the back of the nose gear. They're again shut off, bottle discharges, APU horn, and then of course the light. Biggest problem I've ever seen on this panel is the horn going bad. Pilots will write up that the horn isn't loud enough. You can hear it from the flight deck when it's going off, and they say it's not loud enough. So we've had to change out a few horns. I've done that a few times. But normally there's no problems with this panel. You have an intake plenum that's going to extend from the top of the aircraft right next to the vertical all the way down. It's going to twist and turn a little bit, and then it's going to come into a plenum area, essentially a big box. And then the APU has a KISS seal on it right here, which is just a smashable seal where it's going to fit up in there against it. And that's how it gets all of its air. Of course, it's going to process the air in the engine, and then it's going to exhaust right out of the tailpipe. Okay. One of the hardest things of setting this APU up for a change is getting that exhaust duct lined up, of course. Luckily, you don't have any bathtubs or anything like that to deal with back there. You can see your pneumatic line coming off of here and going forward. You're also going to have electrical lines coming up here, and of course, some of the feedback electronics for the APU that are going to the ECU. The APU is enclosed with 2 clamshell doors on the bottom. I believe there's 4 or 5 latches. I can't remember exactly. And there is an exhaust vent on the side of the compartment. Here you see one of the clamshell doors dropped open. The other one, or actually both of them dropped open. This one on the left-hand side falls all the way down. The one on the right side of the airplane has to be unhooked. So as you're popping it loose, and there are 4 latches, you pop it loose, and then the left side comes on down, and the right side should stay up, and you go ahead and hit the little lever, and it'll come on down too. There is some hold open rods to secure this thing out in case it's windy or what have you, or you don't like it hitting you in the leg. And then, of course, in the door itself is one of your fire loops. Okay. Oftentimes, this gets used as a workbench area, place to set tools and stuff. Just be mindful that there is a fire loop there, and not to stick your screwdriver through the fire loop or anything. And make sure the area is clean when you leave, or you're going to cause damage to that fire loop. This is also pretty thin metal up here, guys. It's really easy to dent and bend. So keep that in mind also. This is our mounting for our APU, and you can see it has 3 mount points, 1, 2, and 3. Now, one of these, and I think it's this one here, will swing out of the way. And it's actually recommended that you do swing it out of the way and tie it off with some safety wire, because it'll cause damage to that intake plenum there on the APU when you're doing an APU change. These are the fish poles that are installed here, which will run which you can use to run your APU up and down. These are the pneumatic ones. You might have pneumatic ones. You might have hand crank ones. Who knows what you have in your station. The other fire loop, well, we talked about the one in the door, but this one right here is up on the ceiling. It doesn't normally get damaged because there's nothing up there, and it's protected by the APU when it's installed. Off to the right here, you can see the feeder wires, and you can see some of the connections hanging loose there. But yeah, that's about it. We go into the next compartment forward, which is the aft stab compartment, and you're going to find a fire bottle when you poke your head in there. I have my head poked in this one, and I'm looking to the left, and I have my fire bottle right here. The opening is right here in the bottom. That's where my head's at, right here. And then this is the APU bleed air duct. This is the air duct that we're getting air from our APU on. This is the APU valve. If you look on your pneumatics panel, This is the one that says APU next to it. This is the one, when you push that button, it's this valve that opens. And then in the background here, you can see the fuel shroud. Now, that's just a big pipe over a smaller pipe, but that is the shroud to prevent, in the event that the fuel line does start leaking, it will leak into the shroud, and then the shroud will take it down to the back of the nose landing, the main landing gear doors, where we have a drain mast that will drip fuel if it does have a leak. Guys, this is a no-go item. If you have fuel coming out of that drain mast aft of the wheel well there, it is a no-go item. You cannot dispatch the airplane with that leaking. This is a little further forward. You see it's right there in the P-dome area. It's in the forward stab compartment. And this is an APU check valve. It is a butterfly type valve, and it has failed in the past. They do get sloppy over time. You can imagine living back there and doing the job every day. The bearings get worn out, and the hinges get loose, and everything like that. So it has been an issue in the past, and we'll explain a little more of that as we get into pneumatics. Our air inlet is right here, and you see we kind of divide it up here. This is about 75% here, and then this is about 25% here. 75% is going to go in. It's going to get compressed twice. It's going to get mixed with fuel, and then it's going to be run through 3 turbines. Those turbines are, of course, going to create movement on the shaft, and the shaft is then going to turn this compressor, which is 25% of the inlet, which is going to be used to make our bleed air. The shaft is going to continue to move forward, and it is going to turn the gearbox, represented here in this brown area. There are labyrinth seals. These are bearings. These black things here are bearings. They're labyrinth seals to keep everything running clean. And then that's really about it. A gearbox, accessory section, load compressor, and then a power section. So those are your 3 main pieces of your APU. Here you see a cutaway, a pretty cool cutaway from Garrett Allied Signal Company. And you can see how the engine burn is right here in this side of it, and then this is your load compressor area right here, and then of course your gearbox area. By the end of this lesson, you won't have a problem figuring this out. It's pretty cut and dry. We're going to look first at the gearbox and its accessories. We're going to look first at the gearbox and its accessories. We have a cooling fan in the top. We have a generator, not an IDG, but a generator. Underneath that generator is a generator scavenge pump. We have a fuel control, an oil pump assembly, and finally a starter motor. This has got a big boot that goes on it, comes around, and then enters into an oil cooler right here. Okay, so that fan pulls air out of the inlet and runs it through the oil cooler. That keeps our oil at the correct temperature. Helps us keep our oil at the correct temperature. So this is real life, and here you see your cooling fan right there in front, and there you see your oil cooler, and then right here is your starter mounting pad. The starter has been removed for this photograph, and then right here you see the fuel control. Directly behind it, attached to it, is the oil pump and the lube assembly, and then of course this black thing right here is your APU generator, not an IDG. Now, whose job of it is to keep this generator on speed? What keeps the generator on speed?
The GCU?
Yeah, the ECU. The APU actually does. They run this APU at the correct speed to give us the correct kind of power we need off this generator. Okay. So they give us the correct speed. Does anybody have a guess as to how fast this APU spins? It's quite unfathomable.
Like 40,000 RPM or something.
It is. It's like 40,000 RPM. It's actually 39,800 RPM. I think is what the exact number is. It's just shy of 40,000 revolutions per minute. Those turbine discs, back there in the back, those 3 turbine discs I showed you, each of those turbine discs weigh about 30 to 40 pounds. They are super heavy. And if it's spinning that fast, I can understand why. It's pretty amazing. I can't even grasp 40,000 RPM. Don't even know what that looks like. Anybody? No. Okay. Yeah. Anyway. Lots of moving parts. Yeah, if the class was in Atlanta, I'd take you downstairs and show you this one. But it's not. So anyway, this is the APU we have on display down in Atlanta in our training center. This was a retired APU from Gull, believe it or not. When Gull went through their bankruptcy, they had sent us an APU to repair. And during their bankruptcy, they lost the paperwork on it. Delta popped it open and looked at it, and they said it's not really worth messing with. And we convinced them that we needed one in the training center. So a couple of the guys in the APU shop took it upon themselves to give us a stand and the APU, and they cleaned it up real good and put some unserviceable parts back on it for us. And now we have a beautiful display. We also have an ECU connected to it, an engine control unit. We can induce a couple of faults into it and make you troubleshoot it if that's what we feel like doing that day. This is, almost 40 years old at this point, this APU. There's not much we don't know about it. There's not much new going wrong with it. But it's been a pretty reliable unit for us. It does have its quirks. It does have its little things that we just deal with. And we'll explain those to you. These are your boots from your fan to your boot to fan and boot from fan going to your IDG oil cooler. They should be intact. They shouldn't have any tears or rips in them, stuff like that. Guys, this ECU originally came with a weight of 38 pounds. It is told by me that this thing actually had glow tubes in it, glass tube transistors and stuff in it. It used to weigh 38 pounds. They've since modded it. It doesn't weigh 38 pounds anymore. And I think it's a little more solid state nowadays. Either way, what you're looking at, though, is it does the start sequence. It's going to monitor your operation. It's going to monitor pneumatics. It's going to do shutdown control. It's going to do the bite. And it's also going to do your predictive shutdowns. Guys, everything on the left is what comes in. 28 volts, start on signal, ECS, demand, environmental control system demand, fire, main engine start, air supply, inlet door, air ground, ADP, has the aircraft model coming into here so we know what it's installed on. Inlet guide vane position, EGT 1 and 2, speed 1 and 2. Load compressor inlet temperature, LCIT. We'll talk about that in detail in a little bit. P2, which is pressure at station 2. PT, pressure at total pressure. I don't know what TP is. Oil temp, low oil pressure, starter power, generator oil filter, and fan valve. We move over here to its outputs, and it's going to give us the run light and the flight deck. It's going to send EGT and RPM to ICAS. It's going to operate the start relay, the APU fault relay, the APU fire control relay, the generator load relay, the air supply relay, the start relay, the fuel control torquer motor, the surge valve, the inlet guide torquer motor, which is how it makes air. It's got a fuel flow divider in it that it's got to control. It's got a de-oil solenoid it's got to operate. It's got a fuel solenoid it's got to operate. It's got ignition, LVDT excitation voltage for that solenoid or for that fuel control. And then finally, 10 volt DC reference something. But those are all the inputs and the outputs of this unit. It does have some bite capabilities, and they are kind of barbaric, but what the heck. You can do a self-test up, lamp test is down. You can click it over here to summary or last run or 2 runs ago or 3 runs ago or 4 runs ago and check to see the faulty LRU and the reason. Under here, there's a switch that erases the memory of the unit. It will perform what we call mini flag tests while it's operating. Typically, that's something that the engine troubleshooting team is going to get involved in, or the APU troubleshooting team is going to get involved in. You guys at Outstations, y'all are kind of a one-man band. There are some checkouts you can do when you are running it. You go up to test, self-test, and it's going to give you some codes. You can take those codes into the manual, and it'll tell you whether it's good or not. They do have codes for a good APU, and they have codes for a bad APU. So you got to, no matter what you get, you got to take it to the manual to decode. In the flight deck, we have a cycle meter on the P61 panel. We have an hour meter. A cycle is when it reaches 95%. A run, an hour meter is going to start logging run hours after 95% speed. We got an APU fault message, which is a sea level message on ICAS. We have 2 status maintenance messages, or 2 status messages called APU oil quantity and door. Finally, over here, we have maintenance level message, which is a byte, an oil quantity, and then a door. Normal indication for the APU is an EGT reading and a percentage of RPM. That's all you get on ICAS. That's all you get. Here you see the monopoles, or the EGT monopoles and the EGT coming into the ECU and then going into the ICAS computers. They're again to be displayed on ICAS. We only get 2 parameters, and that's RPM and EGT. There was an upgrade for oil quantity. You used to be able to get, you can pay extra and get oil quantity. We're cheap. We can go back and check the oil. I think it's about what that comes down to. Monopoles. We have 2 monopoles, and monopoles are going to measure their speed. We have monopole number 1 and a monopole number 2. The number 1 is on the right-hand side of the aircraft. The number 2 is on the left-hand side. So do keep in mind that they do label this a little bit backwards. If you are going to change a monopole, make sure you get the right one. 1 is on the right, 2 is on the left. There is a special socket, a monopole wrench, if you will, to remove the monopole. Looks like you could put a pair of pliers on it, a pair of hog jaws, and unscrew it. Please don't do that. It has a special knurled keyway wrench that goes on there to extract it. This monopole is about 8 inches, 9 inches in length, and it's got a bunch of seals along it, along with a threaded area down at the bottom, where it's going to pick up the motion of the APU drive shaft through a magnet. Any questions? This is speed sensor number 1 in the right-hand side, and there it is coming through the plenum. And then the other one's on the other side. It looks exactly the same. EGT thermocouples. We have 4 thermocouples, and we have 2 rakes. So there's 2 thermocouples per rake. If one rake fails, there's no effect of the APU operation. If both rakes fail and we have not started yet, it will abort the start. If both rakes fail and we are running, we will turn off pneumatics. It will turn off pneumatics, and it will not restart. It is a Cromel-Alumel sensing element, and of course, 4 probes wired into 2 circuits. There you see circuit 1, rake 1, and that's EGT number 2 on this side. And there you see the little probe sticking in the back there. Guys, this little disc right here is what I was saying weighs about 40 pounds without the blades. The disc that holds these blades. That compartment is literally about the size of a large coffee can. It's about how big it is. Any questions? Any questions on speed or EGT? Guys, if you lose both monopoles, it's going to shut down. If you just lose one, it'll keep running. If you lose, if there's a disparity between the 2 monopoles, it's going to assume it's at the highest one. Same with EGT on that. If there's a disparity between the probes, it's going to assume that it's on the highest probe. Okay. Next up is lubrication for your APU. Guys, it's a pretty simple lubrication system. We do a couple of things here that I'll point out. The lube pump is connected to the gearbox, and then the fuel control is connected on top of it. So it's kind of a stacked unit. You'll see a good picture of that in a minute. We do have our cooling circuit. We have had reports, I want to say it was Salt Lake, was finding clogged oil coolers for their APU. And with everything that's happened in the last year and all the parkings out in the desert and everything, this is probably something to keep your eye on. If you got an unusually hot APU or it's faulting that APU, you might have a clogged oil cooler. The air portion of that oil cooler could be filled with dirt and stuff. So keep that in mind. I mean, we did a pretty good job of taping them up, but you know how that goes. Especially in places like Victorville. I mean, you almost wanted to label the paper before you put it over a thing, so you knew what airplane it came off of. Because at the end of the day, there's a whole bunch of pieces of paper laying at the end of the ramp up against the fence. And then, of course, with those sites, they would you'd have Delta's quality department. They'd walk out there and they're like, this one's missing this. This one's missing that. They were all laying at the end of the ramp or across the field in a bush, just pieces of paper that had blown off. Victorville got some nasty winds up there, and the weather was crazy. You'd be 80, 90 degrees during the day, and as soon as that sun would drop, you'd dip right back down into the 50s. You'd have to dress for three different weather patterns. You would wake up and it would be frigid cold from the night. The morning would be like fall. By lunchtime, it was starting to get hot. By the middle of afternoon, it was 100 degrees and there was windstorms coming, sandstorms coming. And then by the time of the evening, the winds would kick up even higher, and you'd have these straight line winds running through the place.
Welcome to the desert. Welcome to the desert.
Yeah. Yeah, welcome to the desert. Yeah, it was pretty brutal. It was pretty brutal.
Hey, Kelsey. That de-oil solenoid valve low temp switch.
Yeah.
We found like in the last 6 months on the 5.7, those things just like snapped off, and you will not get a message.
Huh.
Yeah, it's my partner I work with, like every night, like every time we'd open one, he'd find it snapped off. So he's not allowed to look over there anymore because we never have one.
Now, were you looking up there because there was a problem or what?
No, if we went back there for, check APU oil or something like that, we would find it. I think we found at least 3 or 4 of them. So
Okay.
I have to check the APU compartment now because he's got bad luck, and then he has to check emergency lights because I'm not allowed to look at those.
As long as we know this agreement up front, I'm good with it. Yeah. There used to be several jobs that I would just not touch. Just somebody else has to do that. It's
always a
not that
wire.
it's above me. It's just going to turn into a mess. Typically, anything involving glue or grease. If it involves RTV, door seals, RTV. If it involves the chem packs of the mixed sealer to put on a sheet metal repair. If it involves grease, or lube jobs are normally all right, but anything that involves trying to grease wheel bearings or something, I gotta pass. I will have that shit everywhere. I'll be cutting sealer out of my beard by the end of the shift. It's not going to end well. But anyway, so lubrication system. Thanks for that. De-oil solenoid low temp switch is what he was talking about. He says they've been snapped off. This right here, in case you're wondering, de-oil solenoid low temp. So it's looking at the oil temp and it's trying to see what the temperature is. If the temperature of the engine oil is really low, they're going to activate the de-oiler. Okay? They're going to activate the de-oiler. Here's another view of it right here. The de-oiler is located right in here, and we're going to talk about it in some pretty detail, and you'll know what it does. So thanks for that, Jake. On the side here, let's see, right here and right here, you're going to have the hot sensor and the lop sensor. Low oil pressure, high oil temp. They're located right there next to the gearbox, just into the pneumatic section of the APU. We do have the generator, and we do have a dedicated generator scavenge pump, which is going to go into the dedicated generator filter. Now, here's the deal. Hamilton Sundstrand made the generators and made the IDGs, but they didn't make the APU. The APU was made by Garrett, and so they were competitors in the marketplace. And Garrett didn't want Hamilton Sundstrand's generator to trash its APU, so they gave him a filter that is non-bypassable. And if it does develop differential pressure, it will actually shut the APU down. Okay? So we'll talk about that in a little more detail. Right here, these components right here are for breather air, crankcase breather air going into the gearbox. And I'll kind of explain that to you in a roundabout way as we see more pictures on this stuff. The scupper is on the left-hand side, so that's good. If you drop the door, you can get right to the scupper. Not a big deal. You cannot service the oil while it's running. Just throwing that out there for you. You're going to have to pop the cap and pour it in with it shut down. There was provisions for pressure oil filling, but we don't do that at Delta, so that's gone. There is a sight glass that is virtually useless while the engine's running. There you see the sight glass. There you see the scupper. This one, of course, needs oil. It's below the add line here. There's your full line. There's your scupper. Guys, right here, you see the oil pump. That area right there is your oil pump area. It is mounted on the gearbox with a V-band, I believe. Hold on. There's a weird loop in this thing. All right, there we go. This is our oil compartment, and the reservoir is actually the gearbox. We're going to pull it down here, and we're going to run it through a pressure pump, and then we're going to run it through the air cooler, and then back up and around through the filter, and then it's going to go out and do its work. All right, so we're going to send it here into the gearbox, and we're going to oil all of these things in here in the gearbox, and we're going to provide the oil to that generator. That oil coming out of the generator has got its dedicated scavenge pump, and then it's got its differential pressure, or it's got its filter and a differential pressure switch right here. Okay. Once we know it's clean, we pour it back into the gearbox. This oil right here comes up, and that's where we pick up the low oil pressure and the high oil temperature. We're going to route it along, and it's going to come down here to the mid frame area inside your APU, and then, of course, into the turbine area of your APU. We're going to get it out of here using a scavenge pump out of that mid-frame area, and then it's going to scavenge pump it directly back into the gearbox. This one right here is called a geosynchronous pump, and it's just going to dump it back into the gearbox also. Okay? Now, these other red lines that you see up here, these lines right here, all this stuff in here, this is all crankcase vent pressure. And what we're going to do is we're going to fill up the top of this gearbox with a little bit of head pressure, a little bit of vapor pressure, or a little bit of air pressure, so that we keep the foaming down, okay, so that the APU doesn't get all foamy inside there, and to help all the oil settle to the bottom. All right. Now, in addition to that, we're going to pull some of that pressure out of that gearbox, and we're going to run it into this de-oil solenoid valve that's going to come down here. Now, what line is this coming from my gearbox? That's my supply line into my pump. So why in the world would I want to put air into my oil? Anybody?
Keep it warm.
Keep it warm. When this stuff is cold, it tends to look like molasses. So if it's sitting up at like negative 30 degrees for a while, it's going to look very thick and very syrupy. And what they're trying to do is actually not only warm it up, but they're actually trying to introduce a little bit of air bubble into your oil. And by doing that, it starts to move a little quicker. Okay? And Jacob, that's the purpose of that temp switch. Where's I don't think it's listed on here, but that's the purpose of that temp switch. If your oil is cold, we're going to allow some air into it, and by burping a little bit of air into that pump, just ahead of the pump supply, we are going to increase our likelihood of getting a good oil pressure quicker. Does that make sense? Thumbs? All right, cool. So yeah, that's what we're doing there. Guys, if we don't make oil pressure after, I think it's up here somewhere. Oil temp, speed. We have to make oil pressure within 5 seconds after reaching 95% speed. If we still have low oil pressure indicated, we will, after 5 seconds, if we still have low oil pressure indicated, we will shut down the APU and we'll have to do a restart. Any questions about the oil system in this?
Hey, Kelsey.
Guys, go ahead.
Just in addition to that, in terms of getting that oil and stuff moving,
I'm sorry, Michael, you got to speak up. I can't hear you.
So just an addition to getting that oil and stuff moving, there is a new procedure with the flight crews where at 10,000 feet, whenever they're coming into land, that they move the APU start switch over just to get that the inlet door opened up and to allow a little bit of ram air into there. So it's kind of letting the system just move a little bit just with the ram air and like getting it to stretch out before you actually, when you touch down to turn it on. And that's
Okay.
supposed to help get the oil moving around a little bit and possibly preventing those shutdowns whenever it is that you decide to turn on the APU.
Does it windmill a little bit, maybe?
Yes, that's exactly what it is. You're windmilling it.
And by windmilling it and getting that oil moving around, it kind of breaks up that molasses.
Yep, that's it.
Cool. Now we still have to do in-flight starts.
Yeah.
And honestly, if you get a no light or no rotation, or if you get a low oil pressure, more than likely it's this de-oil solenoid.
Yeah.
How long have they been doing that, Michael?
It's only started within the last month or so, and it's both for
okay.
5.7 and 6.7.
Cool.
I'll send you over the pilot briefing for it.
Oh, that'd be awesome. I appreciate that. Yeah, we're always looking for the latest and the greatest stuff. And of course, I guess that probably all happened during COVID, didn't it?
No.
Not only did I go out and put airplanes back in service, but I took 3 months off, or 2.5 months. I took the leave of absence without pay. I figured I'd just sit at home rather than, because they had us doing doing busy work, justifying our jobs, and I'm like, I don't do busy work. I can stay plenty busy at my house. So, yeah, I wasn't gonna play that game. Anyway, thanks for that, Michael, and I'll give you some more. Were you APUs on the other fleets, or?
No, 5.7.
On 5.7?
Yeah, I'm on the 5.7, but because the two teams merge now, that's the reason why I'm doing this one. I'm just
Gotcha.
for Howard.
Okay, gotcha. This right here is your main oil filter. This right here is that dedicated generator oil filter. Okay. There again, this one is non-bypassable, and if it does clog, if it does have differential pressure across it, it will shut down the APU. The whole theory with Boeing and this APU is that if it can't make electricity, they want to shut it down. No, they don't want to even use it. Okay. So that's kind of where we're at there. What else? This over here on the side, you get a really good shot of the low oil pressure switch and the high oil temp sensor right there. So that's good. And then right here, we have our low oil switch in the bottom of the gearbox. And this is Jake's de-oil solenoid temp switch right there, the one that his buddy finds broken off. Chip detectors, a couple chip detectors. And this is your de-oil valve. All right, so this is your crankcase air going into the top of your gearbox on your APU. And then this right here, that is your de-oil valve. And the next picture I have is going to be a little closer. So we're going to zoom in a little bit. And of course, there's your gearbox regulation inlet pressure right here. And then this right here is that solenoid. And it's connected to this tube. And this tube is going to take air and pump it straight into your oil pump. Right there's your oil pump. Okay. This solenoid, if it's got low oil temperature, is going to open, allowing that crankcase air to run in there. Okay, to help us give us a better shot at getting a good start, a good oil pressure after we get up to 95%. Questions, comments? Guys, if you have a no in-flight start, because we do have to start these, what is it? Michael, you'll probably know better than me. Is it every 30 or 90 days now?
I thought it was every 30 days for the ETOPS fleet.
Every 30 days they do a start? They do an in-flight start?
Yeah, primary altitude start.
from an altitude, and it's supposed to be at the top of descent. It's when they're still sitting up high, about to come in off the track, and before they start dropping down into either into Europe or into the U.S., they're supposed to reach up and hit that switch and try to do a start. Now, Michael's saying that they got instructions now to below 10,000 feet to go ahead and open the door, just turn it to on for a little while as they're coming down.
Kelsey, to be clear, that windmilling procedure, it does not supersede the primary altitude starting as required by the ETOPS program. It's just an amendment, basically.
Okay. And you say they only do that below 10,000 feet?
Correct. Because of the fact that when the crews are coming in, it has to do with the flow of their landing sequence. If they were to do it at 10,000 feet, that's just when their, the ding comes on over the PA when they tell you to, put your tray tables and all that stuff away. And that's why they use that as an opportunity, because anything below 10,000 feet, it will be a little too busy up in the cockpit.
Gotcha. All right, so the opening up and letting it windmill does not apply for the start routine, but at the top of descent, they're supposed to reach up and if they got to do an in-flight start for the ETOPS program, they're supposed to go to start with it. When they release that switch, if it doesn't start, they get another attempt. I believe they have 3 attempts. That is considered one start attempt. They will do it 3 times, trying to get it to start 3 times. If it still doesn't start after the 3rd time, that's considered a single failure. Okay, and that's when we as technicians get the write-up and the setup from the MCC or whatever that we got to go change a part because it failed its in-flight start check. Okay. One of the first things that they're going to have you do, it's almost at this point, it's almost a knee-jerk reaction, is you're going to put a new one of those in it. Okay. Now that's almost a knee-jerk reaction on this. So, and I'm going to show you a couple pictures of the pressurization components. You see a couple of lines coming off the back here. There's the PCD2 pressure line coming in. There's also going to be I think one is right here. It comes up to the shuttle valve, and it all snakes around here. It's kind of a big mess, to be honest with you. Of shuttle valve, you got a shuttle valve here, and then you have a shutoff valve here for your gearbox. And what you're going to do is, at some point, your PCD1 pressure is not going to be enough, and they're going to have to switch over to PCD2 pressure. So that's why we have both 1 and 2, and we have this shuttle valve thing, and it's kind of a hot mess. But we typically don't have many problems with that. The problem normally comes with the with this de-oil solenoid right here. All right, looking a little closer at this generator, we do have that dedicated scavenge pump that's going to run it through the filter before it goes into the gearbox, and it's 35 psi. If there is differential pressure across that filter greater than 35 psi, we are going to go into a generator filter protective shutdown mode. Oh, and the temperature has to be above 46 degrees C, which is about 120 degrees, I'd guess. So as long as we're over 35 psi of differential pressure and over 120 degrees Fahrenheit, we're going to go into protective shutdown mode. Back here in the back, there is a geosynchronous type, georotor type pump to push that oil back into the gearbox. And then, of course, we have a standard scavenge pump here for this mid frame assembly. This is that little tiny generator scavenge pump. The generator's been removed. You can see all the bolts. This is that pump right there, a little tiny thing. Of course, if you have a generator shut down and you pull this thing apart and it's full of metal, pull the filter out, it's full of metal. You're probably going to have to do a new pump too, okay, along with your new generator. This right here reminds me a lot of an MD90 APU generator. Doing a generator on an MD90. I don't know why. Maybe it's just that impregnated metal gasket thing. There was a picture of the rear geosynchronous pump. No big deal. Moving on to fuel system. Fuel is used for combustion as well as hydraulic muscle. So what we have here is we have our fuel control unit. We have our inlet guide vane actuator, our IVG. And then, of course, our fuel flow divider and then 2 fueling manifolds. The 2 fueling manifolds, one of them is a primary manifold, small orifice at about 100 psi, and the second manifold is the large orifice. And then this fuel flow divider. Guys, if you got a no fuel start or a no start fuel issue, go straight after this fuel flow divider. I couldn't think of a more complex way to create a fuel flow divider than what they did. They got an electric piece in there, an electric solenoid. They got 30 PSI check valves, 100 PSI check valves, continuous check valves. They got all sorts of mumbo jumbo in there for a fuel flow divider. If you got a no fuel start, knee-jerk reaction is throw a fuel flow divider at it. Inlet guide vane actuator. This guy right here changes our bleed air by augmenting our inlet guide vanes. And it is a electro-hydraulic servo valve that takes muscle fuel and then moves those valves. Okay? Moves those vanes to either give us air or take air away from that pneumatic section of the APU. It has a whole host of problems. I have a whole slide dedicated to it also. So we'll click on to that. What are we talking about first? We're talking about this stupid fuel flow divider. Yeah. Right here's your 100 PSI check valve. Right here's a 35 PSI check valve. This right here is a drain assembly. Help it drain. There's a solenoid involved. Yeah, it's a hot mess. But on speed is considered 95%. It will have a modified acceleration schedule above flight level 30,000 for increased start capabilities. And I'll show you the starting in a bit. It runs at 100 RPM for normal electric operations and 101% when you ask for pneumatics. This is that fuel flow divider, guys. Super easy to swap out. It's got 1 line on it, or 2 lines on it, and I think 1 cannon plug right there. 1 cannon plug right here, and there's the other line. It's held in by a couple of bolts. Super easy to swap out. There's a little closer picture of it there. It actually looks like it might only be 3 bolts. Guys, we have a set of drains and vent assemblies here on the for our oil galleries and some of our components. Not really a big deal. We do have some telltale drains. You can open up and look and see what's leaking. We do have this drain mask that bolts onto the side. This is going to be different than the 5.7 as far as configuration. The air intake system, there again, is going to come in over the top, right in front of the horizontal stabilizer section box. Believe it or not, you can trim that stab all the way up. And that makes a really nice platform. You can sit up there and work on the inlet door actuator pretty easily. It helps to have somebody else with you so they can run your tools up and down rather than hucking your toolbox way up into that compartment. If I remember correctly, it takes some weird sizes, some bigger wrenches and stuff to do that door. The plenum is a composite material, honeycomb, fiberglass, all sorts of stuff. You're going to have to inspect it during an APU change, so don't forget to do that. This is the intake plenum of the actual APU. This right here is the kiss seal that you're going to squeeze it up against. little note, there is an inspection door right here that you can pull off, and you can look inside there without pulling the whole thing down. Guys, do take a look for debris, especially if you got a no rotation or no light off. You can pull that door open pretty quick, look for debris in there. The guys in the shop tell me a story that they had a carrier, a Middle Eastern carrier, send us over an APU one year to have us look at, and they'd had problems with it. And the guys got it in, they got it off the truck, they started to evaluate it and inventory it. They took the top cover off. And when they took the top cover off, they found a dirty dinner napkin absolutely laid exactly over this square area right here. The story goes is that they took that dinner napkin off. They checked the oil in it and sent it over to the test cell, and the test cell fired it up, and it ran just fine. Called them and told them what we'd found, and sent it back to them, unoverhauled, if you will. Guys, don't forget about the easiest thing first. There's also a story, Abe, rolling around out there where there was a cabin cleaner standing on the back of the turn truck there on the back of the airplane, and they were for some reason jacked up to the right side instead of the left side. But cabin cleaner was standing back there, and he motioned to his other cabin cleaning buddy. He says, "Hey, watch this," and he grabs an empty trash bag and throws the trash bag up in the sky. And, of course, it gets by this door and just sucks right in with the APU running. And evidently the guy got about 2 bags into it. Showed his buddy how he did 2 of them before the mechanic could get up there and get a hold of him. Tell him to stop doing that. You will find debris in these compartments. So, yeah, definitely take a look, see what you got. The one incident I told you about checking the inlet plenum, we had a FOD out of a APU. The boys replaced the APU. They put the new one up. They fired it up and FOD'd out the new one. And that was because of the intake plenum being disintegrated and coming apart. It eating a bunch of material from it. So make sure you do that inspection. There's also a plate here in the aft stab compartment where you can pull this down and do a look of the intake plenum there too. This is another screen going into the for the fan. That's the fan screen there. This right here is damage that happens during removal, and it's one of the biggest gripes to the line guys that the APU shop has. I worked with a guy named Dave Monroe, or is it Dave? Yeah, Dave. No, not Monroe. McIntyre. I worked with a guy named Dave McIntyre, and he left Delta North after I'd been there for a few years. We worked together quite a bit, and he was going to shop life. He was tired of working weekends and nights and holidays, and seniority at Delta North is still at 25 years. So, anyway, he was going to go to shop life, and he's in the shop. He's in the APU shop, and he's like, "This is the number one thing that annoys us that you guys do out there." And what happens is that beam that I showed you that you got to tie off. That's how this happens. As you're lowering the APU with your winches, of course, all of a sudden they're going to go light. And of course, everyone, as soon as they go light, everyone's going to stop, 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 stop. And inevitably, somebody's going to take it and try to shake the APU, try to get it to break free. And what they're doing is they're actually hanging the APU on this lip right here. This lip right here is, it's got a double bend in it. That right there is a 90 bend, and this is another 90 bend to make up the corner. It's a piece of sheet metal that has to be stamped in O and then heat treated and then welded in and all sorts of nonsense. Not to mention you also mess up the P2 line. But this is something that's completely avoidable on the line level when you're removing these things. So just keep that in mind, guys. Make sure you have clearances when you're pulling this thing out. Your intake door has a switch on it so that we know when it's open or when it's closed. It is an actuator installed in virtually a coffee can. You can manually open or manually close this thing if you need to. The intake plenum is made of Kevlar graphite fiberglass composite. So there's that. It's not a bad door actuator to change, although I've only ever done like one of them in my life. That's not to say that we don't have a bigger problem than that with them, but I've only ever had to do one. Any questions about that? Everybody good? Cool. Next is ignition and starting. Next is ignition and starting, and what we have is we have our APU control unit, and it is going to go to the ignition unit and tell it to energize at 7% and then de-energize at 95% once we're running. The ECU is also going to get our door to open, which we see there. And it's also going to get the signal from the, it also gets power from the battery. It's going to provide the starter motor signal to start the APU. There is no TRU left on the 6.7. All the TRUs were retired. All the airplanes with TRUs were retired, so that's gone. Let's see. This is your starter right here. It has a brush wear window. It has a crank pad that you can unscrew right here, and you can hand crank it if you're doing a borescope or whatever of the APU. There is a packing here. Inside of here is something called a Sprag clutch that the APU shop doesn't want you messing with. It requires some special tooling and a special setup. They want the engine troubleshooting team to come out and do it. So if you do change out a starter motor and you look at the Sprag clutch and it is bad or there's a problem with it, they want you to call them out to fix it. All right. Here's something else that's really important. Michael's probably been involved in this too. The starter duty cycle is 3 attempts, followed by a 60 minutes cool down. Guys, I know exactly how this goes. Pilot comes in, he lands, he starts his APU, it doesn't start. Some point during his taxi while he's sitting waiting to cross a runway, he's going to reach up and try it again because he wants his APU running as he pulls into the gate, because that's what they're supposed to do. It's not going to work then either. He's going to call it in while he's waiting at the next taxiway to get clearance. And at that point, we're going to go out, and what's the first thing we're going to do? We're going to reach up to the overhead panel, and we're going to do what? Try to start it. Guess what? Now you're done for 60 minutes. Okay? You're done for 60 minutes. A couple other things about these starters. We've had a real problem with them heat cycling. Does anybody know what color they are? What color is the starter?
Black.
And what is it typically painted with? A lacquer paint, an enamel type paint.
Yeah.
Whatever kind of paint it is, it's the kind of paint that flakes off when it gets hot. Guys, you can go back and you can look at this starter and you can take a good look at it. And if you see a bunch of green primer underneath it and where all the paint's flaked off, what can you assume has happened to that starter?
It's overheated, cycled too much.
Through a heat cycle, exactly. That's a pretty sure indication that your starter's gone through a heat cycle and that you probably need to go ahead and change it. Okay. Not to mention that this 3 start attempt is very often ignored. It's very often ignored. You'll see people try to start this 3, 4, 5, 6 times. and you will trash the starter is what it comes down to. You will overheat that starter and it'll be trashed. So guys, use some of your other skills and go out and look at the starter and see if it's been overheated. You also have a brush wear indicator. I've never had much love with that. So there you go. Here you see the starter painted up in its pretty black lacquer paint. There is a fuse resistor assembly in here. Can't remember exactly what that's for, but there is a little lead that goes on there. This is the cap removed off the back, the cover removed on the back, so that you can either hand crank it, or if you want, you can try to hand start this APU. Get yourself a big drill, the socket on the end of it, put it up there, and try to do a hand start. Remember, you're going to get up to around 40,000 RPM, so just be aware of that. I'm kidding. No reaction out of some of you. Are you even listening? Anyway, inside of here is your Sprag clutch. It's got there's some funniness in there. They don't want you messing with it. Call them out if it's bad. I don't like this start graphic, but I'll kind of go through it a little bit with you. Once we're going to energize the de-oil solenoid if the temperature is below 25 degrees Fahrenheit, if it's below 100 degrees, or 25 degrees Fahrenheit. At 7% of rotation, we are going to start our ignition is going to energize and the fuel solenoid is going to come on. And then somewhere around 42 to 55%, we're going to de-energize the starter, depending upon our altitude. And the de-oiler is going to be de-energized. At 85%, the fuel flow divider solenoid will be energized. And then finally, at 95%, the APU power will be available, the ignition will turn off, and the run lamp will be on. A failure of the de-oil solenoid valve will create a slow or hung start, but the ECU will fault the oil temp switch or starter. The ECU monitors electrical system only. To assist in the starting sequence, ambient air is directed into the de-oil solenoid valve, act as a de-prime the pump, or unloading it for an easier start. So those are a couple of caveats there. This is the acceleration graphic I prefer because it gives you a little bit more idea of what's going on. Within the first 10 seconds, this thing should get up to 25%. In the next 10 seconds, it should go up about another 10, 15%. And if you look, it's got to accelerate at 1% a second across this line right here. And then it has to accelerate at 1.7% a second until it reaches starter cutout on the ground. And then it has to maintain either this trajectory or this envelope trajectory or this envelope trajectory, dependent upon our altitude. And that split line there is at 36,000 feet. So they're going to give this APU virtually nothing on the ground. Thank you. Virtually nothing on the ground for as far as deviating from this line. It's got to accelerate in these parameters or they're going to shut it down. Now, when you're in flight, you got a little more of an envelope here that you can live in. Okay, it can be somewhere around there, but on the ground, it is very strict. Okay, guys, keep that in mind with your starting. It is a timed accelerated start, and of course, you're looking to get it. It should be up and running within 60 seconds. At 100%. It looks like this one's about 45 seconds for the on the ground, and then in the air it's around 50, and then up to 60 at altitude. So, kind of a cool graphic. I enjoy it. Hope you did too. These igniters are just as dangerous as a regular engine's igniter. They do put out a lot of voltage. It can be a lethal shock. Okay, there's your ignition unit. There's a single plug on it. A single ignition plug. It does have an exciter. It is very dangerous. And that's really it for the ignition. Any questions? All right. And now we're coming up upon the Achilles heel of the whole APU system. It's pneumatic power. Guys, we live and die with this pneumatic power, even though it's considered a byproduct. Here we have our what we call our sensors. This is called a pallet of sensors, and I'll explain that here in a minute. This is our ECU, and these are our possible indications. Guys, I've been kind of glazing over this whole ECU thing. Can you guys see what this top box says right here? Is that visual to you guys?
Yeah, reason APU is not operating.
Yes. And then it's going to recommend a faulty LRU. It's going to recommend a faulty LRU. Guys, remember, this is late 70s technology here. Okay? It's not very good. Okay? You can bite this thing, and it can say low oil pressure, and it's going to tell you that the LOP is bad. Is the LOP bad, or is it just out of oil? Which is it? Okay? Guys, don't use this to troubleshoot. Use it to get your idea, to find out what it says, but then go to the FIM and use your FIM. Don't read anything into this faulty LRU business. Okay? Go to your FIM. Even the troubleshooting team will take we'll take phone calls. And hey, I got this going on with this APU on this airplane. Oh yeah, we've been watching that. Try to put one of these on it. Okay, thank you. You know, that sort of thing. We got a couple of sensors we're going to deal with here, and the first one looks like it's the LCIT. The LCIT sensor is located there. It is the load compressor temperature sensor, and it is to protect the APU from reverse flow. Guys, as we take cold air and we compress it, what does that temperature do? Yeah, it goes up. Well, if that air starts to back up in that compressor and this LCIT sensor gets hot, it's going to shut down the APU because it's protecting for reverse flow. Okay? Senses compressor stalls through high compressor temperatures and reports them to the ECU to initiate a protective shutdown. You're going to hear the dreaded okay, which is what these APUs sound like when they shut down. If the LCIT fails, you're going to lose the sensor, of course. It is an LRU. You're going to have no reverse flow protection, no surge protection, and they're going to use P2 for a substituted value. Okay? Now, the next sensor we're going to talk about is P2, pressure at 2. It is an LRU. It's got a programmed value of 13.66 PSI. If it fails on the ground. If it fails in the air, we're going to close our inlet guide vanes. We're going to open the surge control valve. We're going to use PT to replace P2. The APU will provide electrical power only, and the APU will return to pneumatics on the ground. Okay? So what will happen is in flight, you won't have pneumatics. But once you land, your pneumatics will turn back on. And that's typical of a P2 failure. All right? If the pilot's complaining that he didn't get pneumatics in the air, but you go out and check it and it's got pneumatics, gentlemen, you have a P2 sensor failure. Could be blocked, could be a bad sensor. Here is your P2 in real life in its natural habitat. It's right there. And then your LCIT is right here. And then right here, the main event is your inlet guide vane actuator, and your surge valve lives over here. Now, you guys already know that that inlet guide vane actuator is muscle fuel controlled, right? And EEC controlled. Well, your surge valve down here, what do you think it powers it? It's electrically controlled, but it's powered with what?
Fuel. Fuel.
Yes, fuel. I'm sorry, did you just say fuel or pneumatics? It's not fuel. It is pneumatics. I'm sorry. I got distracted. It is a pneumatic actuator. It is electrically controlled and pneumatically actuated. Now, on the 767-400, it is muscle fuel based. It will run off of a muscle fuel. So let's talk a little bit more about this inlet guide vane actuator. There you see the LCIT, and there you see a better picture of the inlet guide vane actuator. Here it is right here. What we're going to do is we're going to send out a signal from the ECU, much like on an engine, give it an indication. This is going to bias the spool. The spool is going to provide pressure to one side or the other of the actuator piston, causing it to either open or close the vanes. Then I got to get feedback, right? Where's my feedback going to go? Back to the ECU. Okay. Meanwhile, my actuator pushed, opened, or closed. Okay. My actuator either extended or retracted. Now, that actuator is a vertical mounted actuator. It comes down into this block assembly, which comes down into this bell crank, which is connected to this rod. Huge problem with this is worn bushings. Okay. There's a bushing right here that goes onto this block assembly. This isn't so bad. Sometimes the bolt's bad, and then you get a bushing in here that goes bad. You'll know this sound because it's called an APU drone. And the APU will drone. It'll run a... It'll be wandering back and forth. It's trying to find its happy spot. And because everything's so sloppy, it moves, and then it moves too far, and it moves it back. And that's what creates that droning noise. And at the same time, the surge valve is opening and closing, trying to regulate its pressure. Okay, so it kind of turns into a hot mess. But it's a pretty quick check. Guys, all you got to do if you got a problem with this thing is pull these two bolts out. There's one bolt there, and there's going to be another bolt down here at the bottom. And you can put your fingers on all these pieces, and you can see how sloppy they are. And you can make sure they're in good shape. So checking for worn parts on this is pretty quick and painless. Highly recommended for a APU that is having issues with pneumatics. This is that inlet guide vane assembly. It's kind of cool. I wish I had a picture of it earlier, an opened up picture. But there is a series of gears right here all the way around this unit. And then there is another gear up here. And as this arm moves back and forth, all of these gears move, and they open them all up and close them all up all at the same time. It's kind of the neat little thing. I will go ahead and tell you that you are not allowed to break this rod end off. This rod end right here stays. You might be able to get that bushing out. I'm not 100% sure. But if something's the matter with that rod, you're done. You got to change the APU. Moving on to the surge system and the control, we have a differential pressure transducer. We have a volumetric chamber right here, and then we have a total pressure transducer. And what we're looking at is we're looking at the volume of air coming out of the pneumatic system. And we're looking at the volume of air coming out of our pneumatic system, and we're trying to regulate it. Okay? All of these sensors go to the ECU. The ECU is then going to come back and give the surge valve a command. Okay? And of course, we're using muscle air, PDC2 for that. And then we're going to exhaust the extra pneumatic air into the APU exhaust. So based on these sensors, PT and PS, and the volumetric chamber there, we're going to set the surge valve position. This is known as a pallet. Okay, all the sensors are typically changed all at once. The surge control system will fail open. APU will run, but you just won't have enough pneumatics to do anything with. If the surge control system fails closed, it'll detect reverse flow, and then shutdown will be immediately after. All right. So pneumatics problems, you can look at your inlet guide vane actuator, but more than likely you're coming after the surge valve or that pallet. There's a good picture of our surge valve right there. There's your electrical connector. And then, of course, you see your pneumatic lines on here. This is a cooling loop for the muscle line on that surge valve right here. We're going to take that PDC2 air, we're going to run it around the APU through this cooling loop and then down to the surge valve. This is it removed. Here we are doing a little inspection of it there. Now, it used to be that these sensors were all located and individually attached to the bottom of the APU right here. Guys, we did away with that a few years ago, and they put everything on a pallet. So now everything is one. Here's the other thing they did is they took the lines off of these sensors. Okay, so when you order this piece, you get a piece of sheet metal with all these sensors mounted on it with no lines. What you're going to do is you're going to disconnect the lines off the sensors up there on the airplane, pull off that pallet, put this pallet on, and then put the lines back in the sensors. Here's what they don't want you doing. They don't want you pulling these lines off because the gaskets were getting doubled up. And the depth that this static probe would stick into the duct would now be in a different spot, thereby causing an inaccurate reading and causing the ECU to mess things up because it wasn't getting a good reading. This is something that we've seen over time, and they've changed. I believe on one airplane they had 3 or 4 O-rings or gaskets packed up in there. So of course that sensor was way down low in the duct and giving us a faulty reading. Okay, that seems to be the latest and the greatest thing we've heard on this. This is the pallet configuration. This right here are the sensors that you're going to be, or the hoses that you're going to be pulling out. Right here and right here. I think there's another one. They're the Canon plugs. But that's the pallet configuration. As far as I know, the old style, which is this style here where they're all individually mounted, those have all gone away. They've all been modified. Mike, is that something you chime in on, or was that before your time?
I don't know what it is for the 6.7. I know the 5.7 that is true, and it was a legacy of Northwest.
Can't hear you.
I said that I'm not too sure of it for the 6.7, but I know on the 5.7 that is the case, and it was a legacy of Northwest. And it also had to do with the ease of changing out some of those components. A lot of damage was incurred changing out individual components. It was easier to just put the pallet as they have it right now.
Okay, thank you. Like I said, I think I've been told that the whole fleet's been done. The odds of you seeing this will probably be on someone else's airplane kind of situation. Guys, all in all, this thing does do predictive shutdowns for us. If we lose both speed sensors, protective shutdown. EGT circuit, we won't restart. We will keep running. Overspeed, overtemp, the high oil temperature, the low oil pressure. If you lose DC power, you unlatch your battery, it's going to shut down. If the door doesn't work, it'll shut down or not even start. If you pull the fire handle, it's going to shut down. If you turn it off, it's going to shut down. If you underspeed it, it's going to shut down. If it doesn't light off, it's going to shut down. If it goes reverse flow, it's going to shut down. You noticing a trend? Anything goes wrong, what does it do? Shuts down. Down here with the monopoles, the highest will win. Control failure, it's going to shut down. If both monopoles go, it's going to shut down. If the control failure, it's going to shut down. Generator oil filter, it's going to shut down. Analog overspeed, it's going to shut down. So their answer to everything, if something goes wrong, is to shut it down. It is an auxiliary power unit. So, as I said before, there are 3 byte tests. There's a pre-start byte. It'll go through a sequence. There's a self-test byte. It'll go through a sequence when you move it to self. And then there's a monitor byte from pre-start to below 7%. There is also something called a mini flag. And that's what the front of the panel looks like. And what happens is you have to turn your head sideways with the APU running. If you hit the lamp switch, you get the mini flag test. And it'll start giving you codes. Okay? Now, these codes are a little hard to see if you've never had to look at them before. But this one right here, that's a bad one there. Let's see. Let me try to use this bright blue. See what happens. So this one here is a what?
$34.
Yeah. And what does this one over here say?
Okay.
Okay. And that's true. It does do those. And now you don't know exactly what they mean. You got to go decode them. But more or less, it'll say, okay. Guys, if you have trouble reading this and it's nighttime, you can get yourself a piece of paper. Grab yourself a piece of paper and lay a piece of paper over the screen, and it'll glow with the number. It'll glow with the number. A lot of folks have a hard time reading through the noise, and what that paper does is it takes all that noise away and just lets you look at a clear white background to see the number glowing through it. How many people think I'm pulling their leg? How many people are like, no way, you're making this shit up, Kelsey? Come on, Derek, are you looking at me that way? Yeah, you are. There's always one. There's always one Thomas in the room. Guys, seriously, I had a student who a week later was still arguing that I was full of it. He finally had to have the other student from another class who wasn't in on the joke go, is that really like that? And he's like, yeah, it is. And it is. It's like that. It gives you these flags. It is true. I'm sorry, Derek. But this was their idea of a byte panel back in 1970. 1979 is when they were building this thing.
And Kelsey, just as an FYI for the guys who may be doubting still, in the FIM, when you go to the APU byte and it asks you to read off those mini flags, it tells you to tilt your head in order to read them off. So it's there in the manual.
We're not making it up, Derek, I promise.
It's more of a, I can't believe they did it like that.
Well, and you also have to remember, we're talking about this being designed in the 70s and produced in the 70s and early 80s. This was cutting edge technology. This was big. This was big time, dude.
Yeah.
You know, you don't have to go back too far in history to go to the 27 when they decided to build an airplane without an APU. And then they decided to put an APU in a 727. They didn't know where to put it. So what do? They put it in the wheel well. They found a spot in the wheel well, and they built an APU to fit in this spot. And it did everything in the wheel well, and it exhausted up through the top of the wing. You know, it wasn't that long ago. But yeah, we've come a long way. As I normally say during the opener of class, this device right here is smarter than the whole airplane. This one cell phone has more computing power than the entire airplane combined, with the exception of IFE. Think about that for a minute. Think about that.
So you think they're gonna start eventually routing all the problems to a certain phone to the plane or something like that?
Routing all the what?
Routing all the problems to a phone?
I doubt it.
I have to disagree on the IFE thing because my iPhone has never failed me, but IFE breaks like every flight leg. So I don't think I've never had to defer my iPhone.
Well, have you been on the new IFE yet, Jake?
Yeah, I work the 220 a lot, and that was
Okay.
Delta Flight Products, and they've kind of got it figured out now, but in the beginning it was like that plane
Yeah.
couldn't take off without an IFE issue.
Yeah. So the new IFE on the 67400 is really stable. It's really nice. I'm actually quite impressed with it. I've used it quite a bit now that they have it all up and running. Yeah, it came out right as COVID hit, and of course now it's all in service now, and they're just starting to mod the 300s to the new interiors too. So that's all good news. I got one video to show you guys before we back up out of this. I don't know how I missed it. Intake door indication. Let's see. And actually, I'm pretty sure it's a test question here. All right, I tell you what, let's not do it that way. Let's do it another way. Linked files. There we go. APU normal start.
Chuck Bauer here, Tech Ops Training 6-7 Group. Today I want to discuss starting and shutting down our APU. I want to start out with two scenarios. The first one, the aircraft is dead and we're going to use the ship's battery to start the APU. The second scenario is we're going to have external power available, but we need the APU for maybe pneumatics or something else. So we're going to go through those two scenarios. We're going to start the APU with only ship's battery. First thing we have to do is select our battery switch to on position. We have our discharge light, standby powered auto, and then we want to make sure that our APU shutoff valve is in the closed position. The next thing we have to do is test our fire detection system to make sure the APU fire detection system works. When we do our fire warning, we want to make sure we get our APU fire handle, our light on the P1 panel, and our warning on the left and right sides of the glare shield. And you can also hear, you'll also get the fire bell. After we do our fire detection test, we want to come over to the P61 panel and do our squib test. We select test 1, ensure that our APU squib illuminates, and it does. And then we go ahead and do test 2, ensuring that APU light illuminates. We did a good squib test. The next thing we want to do is verify we have enough fuel in the left tank. And what we want to do is go ahead and look on our fueling panel, left tank, and you can see right here, we have approximately 24.5, plenty of fuel. The minimum that we need is 1,000 pounds. You can expect to burn about 500 pounds an hour. Now we're ready to go ahead and start our APU. So we come to our start selector, off, on, start momentarily, fault light, saying our fuel valve has transitioned, and then our run light blinks at us twice. The APU generator is usually in. When we do get to 95%, our run light will come on. Because we have the APU generator selected, it will come on at the same time, so the aircraft will come alive when it starts. As you can see, our run light has illuminated, and because we have our APU generator closed, we have power on our aircraft. The run light has illuminated, meaning the APU is up to speed, 95 or greater. And if our APU generator is not selected on, all we have to do is select it on, and our aircraft is now powered by the APU generator. If we desire to turn on pneumatics, all we have to do is select our APU air, valve opens and closes, isolation valves are open, and you can see we have air in our system. Let's go ahead and do scenario number 2. We have external power available and on. We've gone ahead and did our pre-start checks. We're ready to go ahead and start our APU. But the great thing about having power on and ICAS available is we can monitor it. You can see our EGT and our RPM. So we're going to go ahead and start. So when we go ahead and start, we'll go on, start, fault light will come on, and you can monitor right here as the RPM increases to 15%, you'll see the ignition and fuel will engage. As we get closer to 95%, there's our run light. We turned off our pneumatics. Now we're going to go ahead and turn off our APU. But before you turn off your APU, you want to transfer power, if it's available, from the external power. Go ahead and select it. Now it is on. If you do not, and you shut down the APU, you'll go in the dark. So what we have done now is we're shutting down the APU. It will go into a cooling cycle. And what you can see right there, the EGT is dropping off. When the speed reaches 15%, you will see our fault light reappear, cycle through. That is initiating from the fuel valve closing, and our door is also closing at this time. And we've just shut down the APU.
All right. Did y'all get the test question out of that? What does the fault light mean? The flashing of the fault light.
Fuel valve.
Fuel valve.
And when does the run light come on?
95%.
95% from.
Perfect. Perfect. All right. Let me take care of some business real quick. I didn't want to do it while we were watching the video. Anybody have any questions in their book while we're waiting for my computer to work?
Yeah, so you said a double flash at the start. That's for the fuel valve?
That's the fuel valve and the pre-start light.
I missed it, but what sensor measures the bleed air outflow from the APU?
That's going to be the volumetric chamber, PT, and it's It's going to be the pallet. Differential pressure transducer and total pressure transducer.
After a protective shutdown, how do you restart the APU or reset the APU?
You're going to have to go back and do a bite. You can also pull and reset the circuit breaker to the controller, or turn off and back on the airplane. It's got to get that power cycle there to kind of clear its memory.
The APU byte has appeared on the ECS message page. What does this message indicate, and will the APU start or run?
I heard some noise. I didn't really make it all out.
Question number 7. The APU byte has appeared on ECS message page. What does this message indicate, and will the APU run or start?
What page did it come up on? Maintenance?
The ECS message page, yes.
Yeah. So yeah, it should run and start, but it's telling you got to go back and do a bite. What hydraulic system does the gear run on?
Center.
Yep.
And I got one more question. Which fuel pump operates during the battery start of the APU?
So we do have a DC start pump. We do have a DC start pump, and that's available with just battery and standby power on, or just the battery on, and it will help us start the APU. But the left forward boost pump is what runs when the APU is on and we have AC power. And actually, we're probably going to see a lot of this coming up. We're probably going to be seeing a lot of this with all the transitioning of crews. It's without a doubt, and I've signed off a handful of these in my career. I mean, I've done this more than I've signed off APU door actuators. But left forward boost pump will not turn off. Very common write-up on the 6.7 fleet. Left forward boost pump will not turn off. And you pretty much have to put in there that this is the way it's supposed to operate. The left forward boost pump runs when AC power is on and the APU is on. And then, of course, dig the reference out. You probably go into general APU there and do the D&O somewhere in there and call it good. But I've seen that write up many times in my career, and every time it's like, man, you got to know your airplane, pilot. But yeah, it's that left forward boost pump, and you'll see that write up on occasion.
Hey, Kelsey, I got one too, because I don't know if I wrote it down correctly. It's what two components control the flow and pressure of the APU? Air. That's the surge control and the pallet, right?
Read it one more time.
What two components control the flow and pressure of the APU bleed air?
So the pallet is going to help control it, but the physical inlet guide vanes are going to do their job, and the surge valve is going to do its job.
Okay.
What happens if I detect reverse airflow in my LCIT sensor? What's the APU going to do?
Shut down. Or shut down.
Yeah, it's going to shut down. Guys, here it is. When starting the APU, the amber fault light will momentarily illuminate. What does this indicate? And that is that the fuel valve is opening. It doesn't have anything to do with a pre-start bite. Which hydraulic system is the heavy lift system?
Center.
And what are some of the components that we're dealing with here?
A landing gear,
Yep.
brakes.
Alternate brakes. What else?
Primary flight controls.
Yeah, but that's on all of them. Why is center heavy lift? What else?
You gotta run your HMU or the
HMG, the hydraulic motor generator, and the HMG and the flaps and slats. All right.